Welcome to the Beaver's balance. Here, we track how two different quantities change while keeping a natural scale perfectly balanced. The challenge is to keep an unknown bundle of reads on one side exactly equal to a tidy, countable pile on the other, even as those amounts shift. To accurately track this balance, we use three connected tools: an equation, a table, and a graph. These are simply three different ways to look at the exact same relationship. Learning how they work together now makes it easier to understand complex patterns later. Imagine a student who reads 12 pages every day. We'll use D for the number of days and P for the total pages read. This gives us the equation: P equals 12 times D. We can find P by substituting values for D. When D is 3, 12 times 3 is 36 pages. When D is 5, 12 times 5 is 60 pages. Try it yourself. If D is 7, what is the value of P? Since 12 times 7 is 84, we have our third pair. These rows can now be written as coordinates: 336, 560, and 784. By following the rule, we've turned our equation into a set of specific points that we can now place on a graph. Let's look at the equation C equals 1.5 m. On this graph, C represents cost in dollars, and m represents miles traveled. To understand what the point at 4.6 tells us, we need to look at where it aligns on each axis. The first number, 4, aligns with the miles axis. The second number, 6, aligns with the cost axis. Putting those together gives us a clear statement about the situation. A 4-mile trip costs $6. Now consider a runner who trains 8 miles per week. We need to figure out which quantity depends on the other: the total miles or the number of weeks. To find the driver of the relationship, we look at how the scenario unfolds. The number of weeks is the starting point. Time passes regardless of anything else, making it our independent variable. The total miles covered changes based on how many weeks have gone by. Because it responds to the time, the total miles is our dependent variable. Identifying which quantity causes the change helps us correctly set up our equations and graphs. We've seen how an equation generates data, a table organizes it, and a graph maps it. Though visually different, they describe the exact same relationship. Use this template. Blank depends on blank, so the first blank is the dependent variable. Mastering this translation helps you move from basic expressions to more complex algebraic relationships.